สวัสดีครับ Today we learn chapter 6 about the I/O device and security. The objective after you learn in this chapter, I think you understand the I/O interface in computer industrial, and also which one in the I/O device that's obsolete or current in uses in the computer system. And finally, you will know about a C code to program in serial communication. I bring to show you program on the Arduino board and connect to the computer system. Here there are the topics. We have already 4 topics. First, we talk about the I/O port. To show you the I/O port in computer have a lot of the I/O port. I show you the I/O port on computer from the obsolete to current I/O port in computer system. On the left hand side, there are the I/O ports: PS2 mouse, PS2 keyboard, the LPT, PCI, PCIe, serial ATA, PATA, and RS232. If you do the video, you pause the video about 2 minutes and find this words from the internet and which one is serial communication, which one is parallel communication, and you should find about you should search about the speed in communication system. Okay. Now I think you search in it complete. Now I will tell you about detail in each. The first is the PS2 mouse and PS2 keyboards. PS2 is a PS2 protocol announcement from the IBM in 1987 and using the IBM computer. Now you found the PS2 and PS2 mouse and PS2 keyboard interface to keyboard and mouse in computer. But for the new computer we use is in the USB. Because it's USB, you can use the USB hub to extend the USB port and use for the more device connect to the USB port. For the PS2 mouse and PS2 keyboard, it is a send the data in serial communication, but it is not the same format in the RS232 because it's RS232 used in the Arduino system and used in some device that connect to the controller box, but it is a different interfacing. PS2 use the frequency during the 10 to 16 kHz, send is very low speed to sending data. Inside the PS2 mouse and PS2 keyboards have 2 data signals. That is the first pin is a data and the fifth pin is a clock. I show you the pattern response from the PS2 mouse and PS2 keyboard from the laboratory last week. You will see when you press the keyboard it sends the data pattern. The pattern is encoding in ASCII code, but the format sending protocol is different from the RS232. Okay, today PS2 mouse and PS2 keyboards obsolete, replaced by USB. We use USB mouse, USB keyboards, and also send the data in Bluetooth. And the second is LPT. The LPT is a line printer terminals. Now it's obsolete. This is a send data in parallel and connect from computer to the printers. Send data in parallel. Inside the LPT, we can setting it send data 8 bit or 4 bit and set the speed transferring data maximum to 2 megabytes per second. 2 megabytes per second. Today, LPT use a few devices that you found in industrial equipment or legacy printers and CNC machines. The third, this is a PCI interface. The PCI is in this fixture. Maybe you found we found it in the 2 or 3 old computers, 2 or 3 years old computers. This is a sending data in parallel, and this is a maximum bit at the 32-bit system, and it sends parallel cannot the setting or improve speed or changing the bit range. So maximum frequency as only 33 megahertz. In the theory, in the PCI can receive data maximum at 1050 megabytes per second. But for the real thing, when transferring the data, we have some about the communication in the chipset and transferring between chipsets from the device to device. For the maximum transferring data in the PCI, only 133 megabytes per second. Now, I think from the Google, I didn't find a new device used in the PCIs launched to the market. The new device into the market is changing by changes to the PCIe. Before I told you the PCIe, I show you the first. This is a serial the last of the parallel communication. That is a PATA. PATA is parallel attachment. It's used to connect between computer to the hard drive. Inside the PATA has a 40 pin here, and maximum transferring data only 133 megabytes per second. PATA is come together with the PCI, and now PCI is obsoleted. So PATA is obsoleted because it's low speed transferring the data and large cable and having about the not easy to install in a computer because it's a very large cable. For the next one, it is a group of a serial communication. This is a serial ATA, as is abbreviation from the serial attachment. It's used for the serial communication, connect computer to the hard drive, send the data in serial. For when changed from the parallel to serial, the hard drive cannot send it in the 32 bits. It can send in the 64 bit or over. Today, maximum frequency and maximum speed at a serial ATA at 16 gigabit per second. 16 gigabit per second. That is enough for transferring the data from the SSD or the high-speed hard drive or to computer system. The advantage for the SATE is its hot swap. You can unplug hard drive with power. It's not you cannot stop power before the swap the hard drive. This is a hot swap. You can swap hard drive when hard drive is plugged with power. And today SATA replaces in the NVMe on the in notebook and small device because of SATA and hard drive is a difficult installation in a small space, example in the notebooks. So NVMe is a small package and have a PCB installed into the motherboard. It's really simple. So it's used replaces in the notebook and small device. Now the last test is PCIe. The PCIe is a peripheral components interconnect express. This is a high-speed communication in serial communications. Now the PCIe announced in a version 5 that is transferring data maximum to 64 gigabit per second. And PCIe supports the M2 slot. M2 slot used in the notebooks to install another device. Example, a Wi-Fi card, Bluetooth module, sound card, or solid-state hard drive. Solid-state hard drive, some interface is M2, some interface use NVMe. That is a difference. For NVMe is used for the storage, but M2 is used more different device. You can plug Wi-Fi. You can plug the storage state device. This is used for more device interfacing in the serial communication. And the last one is RS232. Now RS232 is obsolete from the computer, but when you do the project IoT to program to control a device, some device send the data in very low speed is used as RS232. By the RS232, the maximum speed at 115 kilobit per second. Now for these lines, on the left hand side, this is a serial interface found is in the industrial and IoT device. And the right hand side is interfacing diagram. This activity matching from left and right. Now we look at in each item. The first is a GPIO. GPIO is used in equipment, in industrial equipment. It have a lot of pins, 40 pins. Yeah, this is a GPIO. GPIO. You can find the GPIO in the Raspberry Pi. It uses a GPIO interface, and some equipment device is use a GPIO. And the next one is I2C. I2C. The I2C uses two cables communication, the transferring the data by control from master and slave. Have a lot of slave connect in one to many. So for the next slide, I show you this is a diagram compare in each type of the serial communication. Now I show you I2C here. The I2C send the data in bidirectional, can send and receive. And for the picture here, this is an I2C bidirectional. And message synchronization. This is a half duplex. Could you remember the half duplex? The half duplex during sender send the data, the receiver waiting until the sender sends the data complete or send a message complete. Now the receiver just starts send the data back, not send and receive in the same time. Just have by the order, by a sequence, and connect from server to client as is many to many, and wide per device is a 2 wide cables. Yeah, this is a 2 wide cables. Sorry. This is a 2 wire cables. And maximum numbers device in I2C maximum at 120x device. That means you can connect slave 120x device. But limitation in the maximum data transfer only 1 megabyte per second, and physical distance in wire cable only 1 meters. Synchronization. Synchronization is a group of synchronization. The next is a RS485 here. This is a RS485. The main point as this RS485 is a distance when distance maximum distance from the device to the last device. That is a maximum distance about about 1.2 kilometers for maximum distance, and maximum device as 32 device. Here the RS485 is have only 2 cables data and connects to cable line as a I2C, but this is a difference in the technique inside the transferring the data. And the next one is a 1 wire. 1 wire is this is a 1 wire. 1 wire used in the interfacing inside the motherboard, inside the computers, not between computer to computer, like as a I2C. I2C you interface inside the computer in a small location. By have a maximum device as a 64 device and 1 wire cable send and receive data. By have a 1 server and many clients. Maximum transferring data as 16.3 kilobit per second, very slow speed for communication. And the last one is a CAN bus. CAN bus is interfacing inside a EV car and in the car system, car communication system, use a CAN bus. For the CAN bus, this is a half duplex and many-to-many communication, have a 3 cables, and maximum at 120x device, speed maximum at 1 megabit per second, and physical distance 40 meters. Okay, now we will focus at IS232 and IS485 characteristics. For the IS232, as I told you, this is a serial communication, and IS232 announcements in 1960. And the IS232 have a voltage during transferring the data about between 3 volt to the 15 volt, depend on system. Some system use a small voltage, 3 volt, that is a short distance. For the long distance, maybe send it and receive the voltage at the maximum at 15 volt. For the maximum cable range, this is 15 meters. And for the IS232 have a main 3 cables, that is TX transferring the data and IX receiving the data and ground. And for the IS232 used in the many application, example in mouse and barcode readers. For the IS485, this is a extend from the IS232 problem. The IS232 have a problem about limitation distance, only 15 meters, and connection 1-to-1. That means I connect computers to a device. When I have 4 devices, I need 4 RS232 ports. I need RS232 ports to connect 4 devices. That is one-to-one communication. For the RS485 improve the connection by connect a maximum at 32 devices per port. I connect a port and connect to the maximum 32 devices. And the maximum distance from computer to the last device at the 1200 meters. 1200 meters. And it's used only T cable. T cable like as the RS232, but difference in protocol interface in size. Inside is half a bit by half a reverse bit. By look at these pictures, bit A is a negative and bit B is a positive. It's do the difference path like as cross talks that we look in the last slide that I showed you about the crosstalk problem. Here this is making for long distance to protect the noise signals. What is the application used for the RS485? Example in car park system. In car park system, we some car parks we will see a red or green light over the car when the car parking is change status from green to red. The car park have infrared or object detection or that is about the ultrasonic. I think it's ultrasonics. When the device is close to the ultrasonics, this is a chain and recognize that is have a car parking here. And in this is have a module connect to the masters. So a master can connect maximum 32 devices in a car park floor. For many floors, this is a communication in RS232 or Wi-Fi or LAN cables connects to the main computer system. This means in each ultrasonic sensors send is to the master here is used RS485. And also in RFID reader and control the door gate is used RS485 to send the message to the computer system. The next one is I2C. This is I2C is a serial protocol interface with 2 cables connect between the device in a small space. Example, in all computer system have keyboard, device, small microcontroller. Their communication in I2C that is transferring data and transferring the control signal, not the long distance because the maximum distance only 1 meter. Example, I2C used in transferring read and write data in EEPROM, that is a memory, or transferring data to the analog to digital or digital to analog. Now for here, this activity I showed you in laboratory to make a pattern character J. This is a J character here, letter J here. This is have a bit sequence like here. is recipient is 100 and 1010. Now I create this pattern by write the code in C language and program to Arduinos. On the Arduino is you connect the oscilloscope to the ground and pin number 1 here, and then you plug USB port to computer and write this program to the Arduino IDE and program to the board. Now I explain you in each line of the program. The program, the first step, we set up the pin mode on board. We set LED on board. This is our output. LED on board. This is a pin number 1. When you transfer the data, the LED here, this is a make a blinking, but this is a on turn off very fast. You see, look like this is a bright, not this is a bright continuous. This is not continuous. This is a blinking very fast. And here, this is a set this function part setting the board as is a turn on and turn off, turn on and turn off. OP is a function name. When I send the X is 0, it sets the LED low, and sets is not 0, it sets the LED high, and high is turn on. And here this is data, and this is a data pattern, and I have a for loop. The for loop is split in the vector here from the first character 0 and send it to the function to turn on and turn off. And this function, this loop for is run very fast, make a delay 1 millisecond. So when you connect the oscilloscope to this port, you will see pattern like this on the oscilloscope. For the serial communication, the serial communication not only sending the data, it have a start bit and stop bit. Here, this is start bit and stop bit. Do you remember the last line or slide maybe in chapter 2, chapter 5? I told you about the overhead when sending the data in serial communication. Here, there are the overhead is start bit and stop bit. And when the serial communication connect with many devices, example RS485. Here RS485 have a computer connect to 3 threads, the CCD camera, In each device have address. In each device have that address. For here, this is slave 1 have address, I suppose it's 001, and this is a have address 002 and 003. When the data transfer in the cable, it send the address. Example, I control here, I send address 002, and then I send bit to check read or write bit and acknowledge bit, and then I send the bit data here, bit data frame 1, frame 2 until stop. Here, this is like as a packet sending the data inside the RS485 communication. That means it have a sequence to control address, to control the device by send address 001 and send data, and then send 002, send data to control device 2, 003 to control the device 3. Here, this is a technique for use a serial communication to control more devices in the same cables. For the communication, when we talk about the communication, maybe you will learn inside the communication and program it in the network programming or network class. But now we will overview the protocol in network topology. For here, this is we call a fully connected topologies by all computer connected end-to-end computers. But here, this is called bus topology by in each computer communication in the same load. Like as the connect to the same cables, this is a look like as connect in the RS485 files. This is a bus system. And here, this is a look like a fully connect topology, but not all cable connect to computers. A few cables connect to computers. And here, this is like as a Wi-Fi system, have a router connect to end device, as is star network topology. Here, this is a look like a bus, but the bus have not by the head and tail, not head and tail have a computer. When head and tail have computer, it will make a link topology. The link topology like as a loop connect from the first computer to second until the last computer connect to the first computers. But here this is a connect in the same load. When I cut some cable here, the link can change from link topology to be a bus topology. Here this is a bus topology. I being the very old device in very old computers. Very old. The old computers connect in the bus topology use coaxial cables connect to the LAN card, connect from computer to computer like as a bus topology. When I connect here, plug here, loop to connect to here, this will be link topology. Now we will do an activity to check MAC address for our device. You can check the MAC address by in Windows. You open the terminal here and type ipconfig /all. That is will show MAC address of your computers. And for iOS, you can look at the MAC address is click setting and about. For Android, click setting, wireless, and about device. Why is this important for the MAC address? Moving back to the here, this device have address 001, 002, 003. That means in each device have the ID, and not the same ID. And in all computer connect to the network internet, in all computer have the different ID name. The ID name in each computer that's called MAC address. So the MAC address value here, or physical MAC address value, this is a difference. All computer is not the same MAC address. Now we will look at write a C code to communication via RS232. For the Arduino AT-Mega32X, this is a block diagram inside the microcontroller. It has a port B, port D, and port C, and here this is a data bus. And in the AT-Mega32X, is have a location port C here, location port D, and location port B. Now when we will control turn on turn off the LED on Arduino, we can set a port to turn on turn off. Before setting the port turn on turn off, we should run the code setup here called function setup. The function setup is set a port location to input or output, to be input or output. For here I set a pin number 13 output. This means pin number 13 here, pin number 13 here, and it is inside connect to the LED. Set is to be output. When I send the data to the Arduino, I should change from output to input. And then in C language, when you write in computers, we have a main function. But in the Arduino, no main function. It have a loop for doing like as the main function. The loop when the program run until to the last statement is moved to the first statement because this is a loop running. Okay, now inside the loop have a loop for. The loop for set the pin 13 high, that is LED bright, and then delay 300 millisecond, and set the LED 13 low to turn off and make a delay 300 millisecond. Now after LED on and off, make a delay 2 seconds and looping back to do it again. Here this is a setting 5 time blinking LED. Why is 5 time blinking? Because it's a loop here have running 5 times. After you run this program, it show 5 times LED beep 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 5 times and then wait 2 seconds. And if you don't have about the Arduino board, you can simulation it on the Tinkercad by put the Arduino on the Tinkercad and write the code. You can run the Tinkercad to simulate the program. Here, this is make a serial communication on simulation in Arduino board in Tinkercad. For the serial communication in Arduino, at the setting, I set the port number 2. This is the input. Yeah, number 2 is input. When I press this button, it sends logic 1 to button to input to start the program. And I set the serial begin speed at 9,600 bits per second. This is speed for transferring the data. And for the loop program, I set the counter output. Here, this is a pin F. It pin number of the counter to text variable str, and then take variable str, send it to the serial communication. And then this is a waiting, get the input from the pin number 2, digital read. This is a read data from pin number 2. If I press the button, when I press the button state is changed from 0 to 1. If state is a count, if state is 1, its counter is 0. Counter is 0 is reset, and then it send white space and make a delay 10 millisecond. The loop is when during in each time it spin the counter 1, 2, 3 until I press the button. The counter is reset. Until I press the button, counter is reset. The loop is a counting 0, 1, 2, 3, 4, 5, counting up until I press the button. The counter will reset. What is the showing the output? It show on the console and show on the serial port. When you connect the serial port TX here, RxTX here to the oscilloscope, you will capture the signal pattern that is counting from 0 to counting up until you press make it 0 on the counter. Yeah, this is an example code. Now the last topic about the making CRC checksum. Why I bring this topic show you here when you transferring or copy data to your friend, it is important that file is infection virus or changing or this file is original or fake. You can check files original or fake files from CRC checking. By here in this concept, you send some data to friends. Example, I send a picture or zip file to your friends. Before I send the data, I bring the file to run a CRC check, and I will have a sequence the number here. I give a file to my friends, and also I give a MD5 parameter to friends. After that, your friend's check is black, and if this file is original, it have a same value, but when it responds different the value, as is maybe it's fake or file inside have difference from the originals. CRC is a cyclic redundant check. This is a technique used for detect the error from digital data. In the window, you can use function or command CERT, UTIL, and parameter hash function and file. And here this is a checking parameter. I use a MD5. For Mac, you type MD5 and file name. The program will show the result, the sequence of the file CRC check. Okay, now I show you the example. I have an original picture here, and then I copy this file to original.png, and I run this code here. The file have a result this, and then I open a program HXD. You can download it from link below here, and I change bit location from DF to FD. You should change only one byte, in file. After I change and I save it back to the original copy.png, and I do hash check again. The value is a difference from the original. That is a claim this file is not original. Okay, here this is a concept for making the CRC check. The last activity, you can do the hashing by check encryption file, and for Windows you can use a hash algorithm to generate checksum by MD2, MD4, MD5, SSA1 until to SSA112. And for the activity in a language, you can use the function OpenSSL and use MD5 to encrypt the text that's sent to the users. Example, I define some text, and here have this is a generate from the text message, and here this is generate after get the text message data. For this is I include text and include the key in hash functions. Okay, now I think complete for this chapter. In this chapter, we know about the I/O device and security, and I think you know the IS-232 and IS-485 is different, and inside the communication and connect to the device. And also, you have an experience use a C language to program on Arduino and use oscilloscope capture signal and understand about CRC checksum in compute in the data when you send the data file to your friends. Okay, thank you. Bye bye.